The maximum breaker size for 6-3 NMB wire is 50 amps. This is determined by the ampacity of the wire, which is the maximum amount of current it can safely carry. According to the National Electrical Code, specifically Table 310.15, B16, 6-3 NMB copper wire with a temperature rating of 60 degrees Celsius or 140 degrees Fahrenheit has an ampacity of 55 amps. However, Section 240.4 D states that overcurrent protection for conductors must be protected in accordance with their ampacities. If the ampacity of a conductor does not correspond to a standard size overcurrent device per 240.6 A, the next higher standard overcurrent device shall be permitted if all the following conditions are met. Firstly, the conductors are not parts of a multi-outlet branch circuit supplying receptacles for cord and plug connected portable appliances. Secondly, the ampacity of the conductors equals or exceeds the rating of the overcurrent device plus any applied load. Thirdly, the next higher standard overcurrent device rating does not exceed 800 amps. If these conditions are not met, then you have to use the next size down. The standard sizes of overcurrent devices are listed in 240.6. A. Common standard sizes include 15 amps, 20 amps, 25 amps, 30 amps, 35 amps, 40 amps, 45 amps, 50 amps, and so on. Because 6-3 NMB copper wire has an ampacity of 55 amps, and the code requires the overcurrent protection to match the ampacity, one might think that a 60 amp breaker could be used. However, due to the limitations described previously, the next size up rule can't be applied. Therefore, the maximum breaker size for 6-3 NMB wire is 50 amps. It is important to note that the temperature rating of the terminals in the panel and the equipment also matter. Section 110.14 Seat 1 states that terminations for circuits rated 100 amps or less are marked for number 14 through number 1 conductors shall be rated for 60 degrees Celsius or 140 degrees Fahrenheit. Number 6-3 NMB falls within that range. Unless the equipment is marked otherwise, you should assume that the terminals are rated for 60 degrees Celsius. If the terminals are only rated for 60 degrees Celsius, you must use the 60 degrees Celsius column in Table 310.15. B16 to determine the ampacity of the wire. In this case, 6-3 NMB copper wire has an ampacity of 55 amps. Always consult the National Electrical Code and local codes for specific requirements and to ensure safe electrical installations. Remember that using the correct breaker size is crucial for preventing overloads and potential fire hazards. Selecting an overcurrent device, such as a fuse or circuit breaker, which is too large for the conductors can lead to overheating, insulation damage, and ultimately, electrical fires. The overcurrent protection device is designed to trip or open the circuit when the current exceeds the safe ampacity of the wire, protecting the wiring and connected equipment. Always prioritize safety and adhere to the National Electrical Code guidelines when working with electrical systems. Ignoring these regulations can have serious consequences, including property damage and personal injury. When dealing with electrical installations, consider these key factors. Firstly, conductor ampacity, which is the maximum current a conductor can carry continuously without exceeding its temperature rating. Secondly, overcurrent protection, which is the use of devices like circuit breakers or fuses to protect conductors from overloads and short circuits. Thirdly, temperature ratings, which specify the maximum operating temperature for conductors and equipment. Fourthly, the National Electrical Code, which provides comprehensive guidelines for safe electrical installations. In addition, remember that proper installation techniques are essential for ensuring the reliability and safety of electrical systems. This includes making secure connections, properly supporting conductors, and protecting wiring from physical damage. Always work with a qualified electrician for complex electrical work to ensure compliance with codes and regulations. When working with electrical systems, safety is paramount. Always to energize circuits before working on them, use appropriate personal protective equipment, and follow lockout/tagout procedures to prevent accidental energization. If you are not comfortable working with electricity, it is best to consult a qualified electrician. Consider the ambient temperature when determining conductor ampacity, as high temperatures can reduce the ampacity of conductors. Adjustments may be necessary to compensate for high ambient temperatures. Additionally, be aware of voltage drop in long conductor runs, as excessive voltage drop can affect the performance of connected equipment. Calculate voltage drop and select conductors accordingly. When installing wiring in conduit, consider the full capacity of the conduit to ensure proper heat dissipation. Overfilling conduit can lead to overheating and reduced ampacity. Also, be mindful of the type of insulation used on conductors, as different insulation types have different temperature ratings and ampacities. Choose conductors with appropriate insulation for the intended application. Furthermore, remember that electrical codes and regulations are subject to change, so it is important to stay up to date with the latest requirements. Regularly review the National Electrical Code and local codes to ensure compliance. In summary, selecting the correct breaker size for 6-3 NMB wire is crucial for electrical safety. The maximum breaker size is 50 amps, based on the wire's ampacity and the National Electrical Code requirements. Always prioritize safety and consult with a qualified electrician for any electrical work. Always refer to the latest edition of the National Electrical Code for the most up-to-date information and requirements. The NEC is updated every 3 years, so it is important to ensure that you are using the current version. Additionally, local codes and regulations may have additional requirements that must be followed. It's important to note that different types of conductors have different ampacities. For example, THHN wire typically has a higher ampacity than NMB wire for the same gauge. Always refer to the ampacity tables in the NEC to determine the correct ampacity for the specific type of conductor being used. When directing conductors for ambient temperature or the number of conductors in a raceway, be sure to follow the directing factors specified in the NEC. Directing reduces the ampacity of the conductors to prevent overheating. In addition to overcurrent protection, ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, provide additional safety protection. GFCIs protect against electrical shock by detecting ground faults, while RFCIs protect against electrical fires by detecting arc faults. Consider using GFCIs and RFCIs in appropriate locations to enhance electrical safety. Regularly inspect electrical wiring and equipment for signs of damage or wear. Replace damaged wiring or equipment promptly to prevent electrical hazards. Be sure to turn off the power before inspecting or working on electrical equipment. Never overload electrical circuits by plugging too many devices into a single circuit. Overloading can cause the circuit breaker to trip or, in more serious cases, can lead to overheating and fire. Use power strips with built-in circuit breakers to protect against overloads. When using extension cords, choose cords that are rated for the intended use and do not overload them. Avoid running extension cords under rugs or furniture, as this can create a fire hazard. Remember that electrical work can be dangerous, so it is important to take precautions and follow safety guidelines. If you are not comfortable working with electricity, it is best to hire a qualified electrician. When working with electrical panels, be sure to wear appropriate personal protective equipment, including safety glasses and gloves. Use insulated tools to prevent electrical shock. Never touch any bare wires or terminals. Be aware of the potential hazards of working with electricity and take steps to mitigate those risks. With proper planning, installation, and maintenance, electrical systems can provide safe and reliable power for homes and businesses. The importance of understanding and adhering to electrical codes and safety standards cannot be overstated. Ignoring these guidelines can have serious consequences, including property damage, personal injury, and even death. Always prioritize safety and consult with qualified professionals when working with electrical systems. In addition to the topics already covered, consider the importance of proper grounding in electrical systems. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. A properly grounded system helps to protect against electrical shock and equipment damage. Also, remember that electrical systems should be inspected regularly to ensure that they are in good working order. Inspections can help to identify potential problems before they become serious hazards. Hire a qualified electrician to perform regular inspections of your electrical system. Furthermore, be aware of the potential hazards of lightning strikes. Lightning can cause severe damage to electrical systems and can even start fires. Consider installing lightning protection systems to protect your home or business from lightning strikes. Remember that electrical safety is an ongoing process. It is important to stay informed about the latest codes and regulations and to take steps to ensure that your electrical system is safe and reliable. By following these guidelines, you can help to protect yourself, your family, and your property from electrical hazards. It is important to recognize that this information provides general guidance and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations related to your situation. Electrical codes and regulations can vary depending on location, so it is essential to verify the requirements in your area. In addition to the topics discussed earlier, consider the importance of surge protection. Power surges can damage electronic equipment and appliances. Surge protectors help to protect against power surges by diverting excess voltage away from sensitive equipment. Use surge protectors on all valuable electronic devices. Also, remember that electrical systems should be properly labeled. Labeling helps to identify circuits and equipment, making it easier to troubleshoot problems and perform maintenance. Use a label maker to create clear and accurate labels for your electrical panel and other electrical equipment. When adding new circuits to an existing electrical panel, be sure to calculate the load on the panel to ensure that it is not overloaded. Overloading a panel can cause the main breaker to trip and can even damage the panel. If you are not sure how to calculate the load on a panel, consult with a qualified electrician. Moreover, be aware of the potential hazards of underground wiring. Before digging in your yard, call your local utility company to locate any underground utilities. Digging into underground wiring can cause serious injury or even death. Remember that electrical systems are complex and can be dangerous. It is important to take precautions and follow safety guidelines when working with electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician. In conclusion, understanding the maximum breaker size for 6-3 NMB wire is essential for electrical safety. Always follow the National Electrical Code and local codes to ensure that your electrical installations are safe and reliable. Remember that safety is paramount and that it is always best to consult with a qualified electrician if you have any questions or concerns. Furthermore, remember that the information presented here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations related to your situation. Electrical codes and regulations can vary depending on location, so it is essential to verify the requirements in your area. By following these guidelines and seeking professional assistance when needed, you can help to ensure the safety and reliability of your electrical system.